In order to optimize output, speed, and safety, engineers have worked tirelessly to reduce the size of today's nuclear technology, with the hopes of creating higher efficiency at a much smaller scale.
When we began this partnership, we wanted to address two challenges with relays in nuclear plants: safety and size. The idea is to reinvent relays on a micro scale, something with a small package, small footprint. So if you have relay logic, which is a technology that goes back decades and decades, predating integrated circuits, let's take that system and apply that to the nuclear power industry.
In this project, we are focusing on very small scale, small footprint, nano to micro scale relays. You can put hundreds, thousands of these things in a small chip and turn them into an integrated chip that can be configured into performing any control action. Most instrumentation and control systems are based on software-based digital systems. So we are developing non-software physics-based technology using electromechanical relays, electromechanical switches based on nano to microscale electromechanical systems made of silicon material system. We use conventional photolithography to write a pattern onto the silicon on-insulator wafer. After that pattern is written, we etch the silicon material at the very top of this to form an electromechanical relay structure on this wafer. You can fabricate hundreds to thousands of these electromechanical relays on a single wafer. They can be interconnected to perform a certain control action, very similar to an integrated circuit. There's an oxide layer that is underneath this silicon material. We remove the oxide layer, which releases the moving part of the electromechanical relay. The last step is metallization of this structure, and metal provides our connection to the outside electrical signals. You apply an electric field and you perform an electromechanical action of what we call a cantilever that provides the switching action.
It's all the high-resolution lithography that allows you to make things really, really small. If you talk about the size and the scale of these types of devices, and if you think about a human hair is on the order of 100 microns in diameter. These things are a fraction of that. Some of the relays go from the 100 micron scale, and then other ones go down to just a factor of 100 times smaller than that, so just a small fraction of the size of a human hair. Over the decades, the ability to pattern things at extremely small scales has improved many times, so we're just taking advantage of integrated circuit fabrication techniques to make essentially little micromechanical devices that are similar to the relays of the 1940s and 1950s. It really makes this technology extremely inexpensive to implement.
It comes with significantly reduced maintenance costs, therefore lower cost of ownership. It is not software-based, therefore it is immune to cyber exploits and software errors. People should be interested in a reconfigurable system for their needs that is based on physical electromechanical relays, no software. That is a potential game changer for a lot of applications.